Hello students, welcome to yet another session of the YouTube live classes of Brilliant Qatar. Today we'll be discussing on the topic of differential equations for chapter 9 of your grade 12 mathematics. And before we start with the session, I request all of you to share the link with your friends and ask them to join immediately before it's too late. And if you have not subscribed to the channel yet, I request all of you to please subscribe and get updates, regular updates on our live sessions and recorded sessions of Brilliant Qatar. Let's straight away go to the topic of differential equations. And in CBSE Board Examination is expected to be having at least 2 MCQs from this topic, and we can easily anticipate which are those questions going to be. Yes, so let's go through the questions one by one, all of you. The first question we're going to discuss today is the most important question we are expecting from this topic. It's the order and degree of a differential equation. So first of all, let's try to understand what is the order of a differential equation. Order is the highest derivative in the differential equation. We can see that in this differential equation, you have a second order derivative, you have a first order derivative, and another second order derivative. And the highest order is the second order. So we can clearly say that the order of the differential equation is 2. Yes, the order of the differential equation is 2. Now, degree, you should be careful. Degree is something you should be careful about, because degree cannot be always stated very fast. You should make sure that all the differential coefficients that you have in this question, like differential coefficient means the derivative forms you have in this question are in polynomial form. They are inside polynomial functions. Can you see that the second order derivative over here is inside the trigonometric function sine, which is non-polynomial? Sine is a non-polynomial function and it contains a differential coefficient. Then definitely degree is not defined. So when do you say that degree is not defined? When do you say degree is not defined? When any of the differential coefficients are inside a non-polynomial function, we say it's a degree which is not defined. So from this, we can easily say the option to our answer is order 2 and degree not defined. Yes. So once again, order of a differential equation is the highest derivative present, and the degree is the power of that. So normally students who are not careful will simply go and say the power of the highest order is 2. So let me say the degree is also 2. No, in this case, one of the differential coefficients are inside a non-polynomial function. Yes. Answer option D, right everyone? Okay, good. Now let's go for the second question, the order and degree of a differential equation. Now the problem here is, again, order is very easy to say. Yes, no doubt we can straight away say order of the differential equation is the highest order here. Yes, that's once again the second order derivative, which is equal to 2. d squared y by dx squared is the second derivative, so we can say order is 2. But when we look at the degree, what happens is we can see that the power 3 by 2 in the numerator, the power 3 by 2 in the numerator, and according to the definition of a differential equation, the degree can be stated only if it's in a polynomial form. But if the power is a rational form like 3 by 2, you cannot say it's a polynomial form. So this is a polynomial form. So this is a non-polynomial form which can be converted to a polynomial form. How? That's because you can simply write this differential equation as rho into, this symbol over here is rho, okay? Rho into d squared y by dx squared is equal to 1 plus dy by dx the whole squared, the whole raised to 3 by 2. My problem is the 3 by 2, the denominator 2 in the rational power. So I'm going to square both sides. Yes. What's the idea of such a question? Square both sides. So what happens if you square both sides? You get rho squared d squared y by dx squared whole squared equal to 1 plus dy by dx the whole squared the whole raised to 3. Now I have got a function which looks like a polynomial form. Yes, it's a polynomial form in terms of the differential coefficients. So can you please tell me now what's the degree of this differential equation? What's the degree of this differential equation? Now all of you can see that the power of the highest derivative is 2. Don't say 3. It's not 3 because 3 is with respect to the expression 1 plus dy by dx the whole squared raised to 3. This is only first order. Degree is always the power of the highest order, where it's 2 this time. So it's 2 and 2. So we can say my option is order 2, degree 2, option A. Yes, Joel, right answer, option A. Dhruvil, right answer. Yes, others also please try to give answers. These are very, very simple questions to say. Once again, this is the type of differential equation where degree can be found out by making some sort of numerical adjustments. Okay, it's not a non-polynomial function to get degree which is not defined. So let's go for the next question now. Question number 3 again. Can you see that the question talks about square root of dy by dx? Yes, it's minus 4 dy by dx minus 7x equal to 0. So without any modification, you can straight away say that my order is equal to, the highest order in this question is straight away 1. Yes, dy by dx is the highest derivative you can see in this expression. Now I'm going to try to rearrange it. Square root of dy by dx is equal to 4 dy by dx plus 7x. Now I have to get rid of this square root, which is a non-polynomial function. How to get rid of a square root? Again the same idea, square both sides. So what happens when you square both sides? This becomes dy by dx. This becomes 4 into dy by dx plus 7x the whole squared. Now my dear students, you can see the right hand side is squared. It's an MCQ question. Please don't waste your time trying to open that a plus b whole squared. And you can easily see that when you open with a plus b whole squared, the power of the 2 will be reflected on the term dy by dx. So you can see that the power over here for my differential coefficient term will become 2. Yes, so my degree is 2 and not 1. Degree is 2 and not 1. So order 1, degree 2. Order 1, degree 2, option D. Order 1, degree 2, option D. Yes, now I think everybody is now very clear about finding the order and degree of a differential equation. Yes, all of you try to give answers on your live chat. Please make sure you're attending the class properly. Make use of these kind of questions, because order and degree is the most anticipated MCQ question from differential equations. Okay, let me move on further. One more question with the power which is rational, because I think it's going to be the most expected question this year with a rational power in the differential coefficient. Can you see the power is 2 by 3? But first of all, look at the expression and please can you tell me what's the order of the differential equation? What's the order of the differential equation? Yes, can you please try to give answers? What's going to be the order of the differential equation? The highest order, yes, you can see that the highest order is the power over here. Yes, d cube y by dx cube. So my order is 3. My order is 3, right answer. Okay, order is 3. Now I have to get rid of this 3 in the fraction. Yes, so that I get the power in the form of a polynomial. So I am going to cube both sides. I am going to cube both sides. When you cube it, your left hand side is 1 plus 3 into dy by dx the whole squared is equal to d cube y by dx cube the whole cube. Therefore, what's going to be my degree? The power of the highest order derivative. The power of d cube y by dx cube is 3. That's going to be degree 3. Order 3, degree 3. My answer is 3, 3, option C. Yes, right answer Samuel, Abin and Drivil. Okay, so my order is 3, degree is also 3. Now let's move on. Yes, now we've done enough questions with order and degree, but the concepts based on order and degree doesn't finish here. Wait for more important questions. You're going to get more important questions based on order and degree. Please, order and degree is just not, finding order and degree of a differential equation is not the only pattern we are expecting this year for the boards. So wait for more questions coming later. Now let me go to the most basic question once again. The second most expected question from differential equation is finding the integrating factor of a differential equation. Normally integrating factor comes for differential equations which are called linear differential equations, right? Integrating factor exists only for linear differential equations, and we have learned there are two types of linear differential equations, right? The first form is dy by dx plus p into y equal to q, and in this case we can say the integrating factor if is e raised to integral p dx. The second form is dx divided by dy plus rx equal to s. Now in this case my integrating factor is going to be e raised to integral r dy. Yes, so we have to understand which form is this, because when they ask you integrating factor, it should be written in either of these forms, right? Normally you can see that this expression holds a py and this expression, the second one, holds an rx. Okay, if you look at the question here, just have a close look at the question, you can see that you have a y, and every term in this differential equation is in terms of x other than that y. So we know that it's type 1. It's definitely which type? It's type 1, not type 2. So I will try to write it as type 1 by divide x log x. Why divide x log x? Because according to type 1, the coefficient of dy by dx should be 1. And you can see the coefficient of dy by dx is x log x. You divided, your new differential equation is dy by dx plus 1 by x log x into y equal to 2 divided by x. The log x will cancel off in the numerator and in the denominator. You get 2 by x. Now I got the correct form. I can easily tell this is my p. So therefore my integrating factor equals e raised to integral 1 by x log x dx. Substitution method, no doubt, you can substitute log x as t. And what's the derivative of t? You get 1 by x dx. 1 by x dx. So this is e raised to integral 1 by x dx is dt by log x is t. That is equal to e raised to log t. E and log are inverse of each other, and whenever they come close to each other, they eliminate themselves. So answer is t, and t is definitely log x. And let me remind you once again, simple questions where you can easily find the integrating factor are highly expected this year. The second most anticipated question for 1 mark, finding the integrating factor of the differential equation, and you can say that it's log x. Answer is option B, log x. Yes, right answer Samuel and Dhruvil. Good answer, keep it up. Now you can easily understand which type of differential equation, linear differential equation we are talking about, and take the term with respect to the integrating factor, find it. And most of the times it will be substitution. Most of the times it will be substitution, and most of the times it will result as a log. So E and log will most of the times eliminate themselves. Okay, let's move on with the next question now. Question number 6. The solution of the differential equation. Okay, now when a question based on solution of a differential equation comes, most of you think that it cannot be asked for MCQ. No, it's not like that. It's not like that. We could be asked questions based on solving a differential equation as an MCQ. But it could be very simple questions. Okay, it might be like 4 or 5 steps. Who cares? But integration based questions, we cannot say all the integration based questions are going to be like 1 or 2 steps. MCQs based on integration can go up to 4 to 5 steps. We have seen this in the past years also. So please do not anticipate that a question based on solving a differential equation will not come for MCQ. It might come. So please look at the question over here. dy by dx equal to e raised to x minus y plus x squared e raised to minus y. Okay, now e raised to x minus y. You can write e raised to x minus y as e raised to x into e raised to minus y plus x squared into e raised to minus y. And what I felt was, I've seen many questions in many books based on solving a differential equation for MCQ, and in most of these questions I have seen the question was asked with respect to the exponential functions and the properties of exponential forms. You can see that the powers are being subtracted, but I'm not going to divide the powers because I see that I need e raised to minus y in both the terms. Yes, so I can take e raised to minus y common out, and inside the bracket it's going to be e raised to x plus x squared. Now you're going to make it as a separable differential form. You're going to get dy e raised to minus y will come to the left side as e raised to y, and on the right side it is e raised to x plus x squared into dx. I have separated the terms of x and y on both sides. Now I can simply integrate both sides. What is the integral of e raised to y? It is e raised to y. What is the integral of e raised to x? It is e raised to x. And what is the integral of x raised to 2? It is x raised to 3 divided by 3 plus c. Look at all the options. Do you see any option which matches our answer? Do you see any option? Look at option B. If I make a simple arrangement like this, e raised to y minus e raised to x equal to x cube by 3 plus c. Do you see this option in option B? Yes, we can straight away say the answer is option B. Yes? Yes, very good. Samuel, Dhruvil, yes, Shadi and Nitin, you've done right answers. So please, all of you, I think you understood the concept, right? Yes. So solving a differential equation, and most of the times the question anticipated from this is the separable form of exponential functions. The separable form of exponential functions. Okay, next question please. Question number 7. Solve the differential equation dy by dx plus y equal to e raised to x. Again, don't think this is a separable form. Can anyone in the class please tell me, if you're trying to solve this differential equation, what type of differential equation do you identify in this question? It's not separable. Definitely it's not separable. Yes, Nathan, very good. The answer has already come. It is a linear differential equation, and definitely there is a single y sitting in the equation, so I can say it's type 1, the first type of LDE. What is it? It is the first type of LDE, and in the first type of LDE it's already in the required form. You have no headache. It's already in the required form. It's 1y equal to e raised to x. So if I say this is p and if I say this is q, my integrating factor is e raised to integral p dx. E raised to integral p dx. That is e raised to integral 1 dx equal to e raised to x. So what is my integrating factor? What is my integrating factor? E raised to x. Now, what's the technique to solve an LDE type 1? I will write both the methods here. Solution of LDE. LDE, again, don't think it won't be asked for MCQ. It could be, because finding the integrating factor for this is so easy, and we have a shortcut method to find the solution of an LDE. The first type solution is y into integrating factor equals integral q into integrating factor. Y into integrating factor. So when you have this method, you can easily tell the answer, right? For the second type, of LDE, it is x into integrating factor, because in the second type, the standard variable is x, integral s into integrating factor. Please refer to your notes. You will see this in your notes. Okay. Now, the answer is so simple here. Y into integrating factor equal to integral q. Q is again e raised to x. Q is again e raised to x into e raised to x, which is e raised to x the whole square. Okay. Now, how do you integrate e raised to x the whole square? It's actually e raised to 2x. Is the integral of e raised to 2x. So y e raised to x is the integral of e raised to 2x, which is e raised to 2x divided by 2 plus c. For the first time, you solved a differential equation and you're going to see what is going to happen to the c. Listen very carefully. C is not a simple thing to handle with, but it's an arbitrary constant which has the capacity to be any constant you like. Right now I'm writing it as 2c, but remember 2c, I'm multiplying 2 to the arbitrary constant. It becomes a new arbitrary constant which can also be called as c. Now look at the answers we have. We have 2y e raised to x is equal to e raised to 2x plus 2c, but remember 2c is still an arbitrary constant which can also be reconsidered as arbitrary constant c. That is the power of an arbitrary constant. It can be reciprocated, it can be put with a minus, it can be multiplied with a constant, it can be added with a constant, but still it will come back to the old form c. Now if you think like that, my answer is option C, right? 2y e raised to x is equal to e raised to 2x. Please don't sit and argue, sir, I got 2c, but there is no answer in the option which gives 2c. Don't worry. That's why it's called an arbitrary constant, which can be an any constant. Okay? It can be written as 2c, 3c, minus c, 1 by c. Okay, c plus 2, c plus 5. Everything is the same answer. Yes, Nitin, right answer, option C. Okay? Moving on with the questions now. Listen carefully. Moving on. Again, solve the differential equation, and dy by dx is equal to x plus y by x, satisfying the condition y of 1 equal to 1. What is the meaning of this? This means that y is equal to 1 and x is also 1. It simply means what? Y is 1, x is 1. Why is the set of values given to us for x and y? One simple reason. What is the reason for giving us a set of values for x and y? It's simply to find the arbitrary constant in the last step and substitute it back, and we get a new solution called as a particular solution. Yes, very good, Nitin. It is to find the particular solution. Okay, so the previous question we left it in terms of C and it's called a general solution, but when you come to the question with set of values for x and y, you can call it as a particular solution. Okay, now anyone, can you identify what type of differential equation you see in this question? Does anyone have the confidence to say what type of differential equation you see in this question? Is it separable? Is it homogeneous? Is it linear differential? Yes, I'm getting an answer which says homogeneous here. Any other options for anybody here? Anyone else feels I can do it something else here? No one else? And definitely I wouldn't say this is homogeneous, because homogeneous is too complicated. Yes, I expected everybody will say homogeneous, but it's too complicated for a yes, Shahi, right answer. It's linear. Yes, Shadi, right answer. It's linear. So how does it become linear? Just split the numerator on the right side. You will get 1 plus y by x. And then bring that y by x to the left side. You will get dy by dx minus y by x equal to 1. Now it looks like an LDE where P is minus 1 by x and Q is 1. See that? Just observe, my dear students. You just have to just look at the question for a minute, or maybe like 10 to 15 seconds spent with the expression. You will be able to identify it. How could I identify it? Because I saw this y. All of you, I saw this y. Okay, just look at the y that is given to me in this question. So I always have this idea, like if I have a single y or a single x sitting alone with every other term in the expression is in functions of x or y, then I can call this as an LDE. That idea is always there with me. Okay, now tell me, what is the integrating factor we have here? E raised to integral minus 1 by x dx, which is e raised to minus log x. Can you see e and log coming? But there's a minus sitting in between which is disturbing us. So I will say e raised to log x raised to minus 1. Isn't that the property of log, to take the coefficient of log as the power inside the log? Yes. So it's going to become what? E and log will eliminate x raised to minus 1, which is 1 by x. And the solution of LDE type 1, again the equation y into integrating factor is equal to integral q into integrating factor, and your answer is y by x equal to integral q is 1, so it's 1 by x dx. So my answer, final answer is y by x is equal to log x plus c. So y is equal to x log x plus cx. Now I have to substitute the value of x and y. X is 1, y is 1. X is 1, y is also 1. And when you put log 1 is 0. Log 1 will going to become 0, and your answer for c is equal to 1. So my final answer for the solution is y is equal to x log x plus 1 into x, which is again x. Y is equal to x log x plus x. So option A. Y is equal to x log x plus x. Option A. Okay, I think everybody understood this. Yes, because I'm explaining it too much, you feel it's too lengthy. No. If you are a very good student who is very clear about what's an integrating factor and what's the solution of an LDE, you can do integrating factor in 1 or 2 steps. You can do the solution in 1 or 2 steps. Yes, so maximum 4 to 5 steps you can finish this entire answer, and it's not a complicated integration to be afraid of. Integral of 1 by x is just simply log x. So an integration question for MCQ, don't expect it's going to be 1 or 2 steps. No, you have to be doing 3 or 4 steps minimum. Okay, get it? So let's move on to the next question. Question number 9. The solution of, again it's an integrating factor based question. Okay, please tell me, P is a straightforward question. P is equal to tan x, Q is equal to sec x. So what is the integrating factor here? E raised to integral tan x, and integral of tan x is log mod sec x. Again e and log will cancel. Your integrating factor is sec x. What's the integrating factor once again? Sec x. Solution. What is the solution? Y into integrating factor is equal to integral q into integrating factor sec x into sec x, which is sec squared x, and the integral of sec squared x is tan x plus c. So my solution is y sec x equal to tan x plus c. Option A. Y sec x equal to tan x plus c. Yes? Please keep it simple. Please keep it simple and neat. And please practice doing this, because anyway you are expecting LDE for 3 marks also. You're expecting LDE and homogeneous for 3 marks also. Practice them properly. It might help you a lot to get the 1 mark in MCQ also. Okay? Integrating factor at least might come for a 1 mark MCQ. Just find the integrating factor of the LDE. Moving on to the next question. Question number 10. The solution of this differential equation represents what? This is another type. Solve it. When you are solving a differential equation, you will come to an equation, and that equation represents what curve or what geometrical shape. Okay, so we have an equation like x dy minus y dx equal to 0. It's a simple separable form. X dy equal to y dx. Separate it. Dy by y equal to dx by x. Simple integration on both sides, right? Simple integration on both sides. What is the integral of 1 by y? Log y. What is the integral of 1 by x? Log x. And let me give you an advice. Whenever both the integration in the solution of a differential equation results in log, both sides it's log, then make sure you write your arbitrary constant also as log c. If any one of them is not log, no problem. If any one of the integration part does not result in a log, no problem. But if every other term other than the arbitrary constant results in a log, please put log c. Yes, I got the right answer already from Nitin. Yes, good answer, Nitin. So let's write it as log y is equal to log a plus log b log ab. Yes, so my final answer, I can take out log from both sides of the equation. I can write y is equal to cx. And is there any equation which looks like this, or any geometrical shapes equation looks like this? Yes, Dhruvil, right answer. Samuel, right answer. Now it definitely looks like this form of an equation. Okay, let me not call it as c because already c is being used. Mx plus k. Have you seen this before? You've seen this in grade 11, straight lines chapter, the slope intercept form of a line. But do you see that here the k does not happen here, so that this is 0. The intercept is 0. The intercept is 0 means it passes through 0. Passes through 0 means its origin. So I understood that it is a straight line and it passes through origin as well. Option D, straight lines passing through the origin. Yes, straight lines passing through the origin. My option is option D. Straight lines passing through the origin. This is another anticipated question. I have one more question like this coming later on. Okay, but this is a simple question which can easily come for MCQ. Okay, straight lines passing through the origin. Just solving it, you should be able to identify. And you have been taught to identify the different types of curves which you learned in 11th standard. In grade 11 you have learned in chapter 10 straight lines and chapter 11 conic sections. You have learned the different types of geometrical shapes there and their equations. If you're able to identify those equations, and you've learned in 12th standard also in applications of integrals how to identify from the equation what geometrical shape it represents. So if you learn that, you will be able to do questions like this. Otherwise it's difficult. So please go back to grade 11, or you can use the applications of integrals chapter to identify the different functions and their geometrical shapes. Okay, next question number 11. Solve this differential equation. Again, sticking on to these basic questions, I want to solve these differential equations. Log dy by dx minus a is equal to 0, it's equal to a. Now can I say this is dy by dx? If I invert log, I will get the exponential form e raised to a. Now it's too simple to rearrange them and get to the answer. Dy is a constant e raised to a dx. Integral of dy y. E raised to a is a constant multiplied with x plus c. So what's my final answer? Y is equal to x e raised to a plus c. Y is equal to x e raised to a plus c. Option A. Simple questions. Again, repeatedly telling you, simple solutions of differential forms are important for you people. Okay? Don't skip them. It's very important for you. Question number 12. Yes. This is the next type. Like I said, order and degree. In the beginning, few questions we discussed about order and degree. Those are questions where you people always focus on, and you know how to find order and degree. Everything is fine. But there is one very important relationship that exists between the order of a differential equation and the number of arbitrary constants you get at the end on solving the differential equation. So before going to that, let me show you something. You solve this differential equation, right? Over here. And what was the order of this differential equation, all of you? Look at this. Isn't it dy by dx with order 1? And when you have an order 1, you got one arbitrary constant called c. So the relationship that exists between the order and the number of arbitrary constants is order of differential equation equals number of arbitrary constants in the general solution. Okay? Number of arbitrary constants in the general solution. Now read the question once again. A differential equation has order 3. Then the number of arbitrary constants in its general solution. Order is 3. Then what is the number of arbitrary constants? Definitely going to be 3, right? Yes, that's what I said in the relationship here. Order is equal to the number of arbitrary constants in the general solution. So you can simply take option C. Yes? Yes, you have been taught this in class, I know. So you have said the right answer, Nitin and Dhruval. Your answer is 3. So order 3, number of arbitrary constants in the general solution is also 3. Simple answer, right? Let me see how many of you can give me the correct answer for this question. A differential equation has order 2. The number of arbitrary constant in its particular solution is. Right answer, Nitin? Anyone else? Anyone else likes to give the answer for this question? Come on. It's an easy one, right? Just now I said. So you can easily tell the answer for this. Yes? Yes, Abdul says one option. But why can't it be C? What C? What C are you saying? Like 1? Many of you are saying option A, but those who said option A, your answer is wrong. That's what. Please read the question. It's about particular solution. That's why I was waiting for the answer. Now you will never forget this. Yes, Sana, right answer. Yes, Dhruvil, right answer. It's option B. Number of arbitrary constants is 0. Why is that? Because for a particular solution, right answer, Dhruvil, we find the arbitrary constants by substituting the values of x and y, and we get the exact value of that constant and we substitute it back in the differential equation. Then after getting the particular solution, there is no more arbitrary constants in the solution. So when this crucial word is seen in the question, careful, they are very tricky. This question is there in the textbook as an example of an NCERT MCQ in your NCERT textbook. Okay, the number of arbitrary constants in the particular solution. Okay, in the particular solution of an differential equation. Answer is 0. For particular solution, 0. That's why my definition is very clear. I mentioned the word general solution. Okay, I did not say this in the beginning, otherwise you will not be very careful about this. Now nobody will forget why this is 0. Get it? Okay, now let's move on to the next question. Question number 14. The differential equation of all circles in the first quadrant. The differential equation of all circles in the first quadrant which touch the coordinate axis. So I'm drawing a circle and this circle touches the coordinate axis in the first quadrant. Let's say if this is the point A, then definitely this will also be A. No doubt. This is A comma 0 and this is 0 comma A. Then definitely the coordinates of the center of the circle is A comma A. Yes? And can anyone in the class please tell me what is going to be the radius of the circle? Radius of the circle. Yes, right answer. That is also going to be A. So what is the equation of the circle? 11th standard. See, conics coming back. Geometrical shapes are very important for differential equations. Equation of the circle is x minus h squared plus y minus k squared equal to r squared. Do you see that to write the equation of a circle, I need 3 constants, h, k and r. What are the coordinates of the center? H and k, center h and k, right? Center h and k and radius r. And the coordinates is x minus a squared plus y minus a squared equal to a squared. Tell me how many arbitrary constants you see in this equation. Only one. How many arbitrary constants? All of them are now A. So you say arbitrary constant equals number of arbitrary constants equals 1. Then if your arbitrary constant is 1, what will be the order of this differential equation? Right answer, Dhruvil. Yes? Can I say the order of the differential equation is going to be also 1? Yes? The circle touches, because it is touching the coordinate axis. Because it is touching the coordinate axis, this magic happened. So just write the equation of the circle which touches the coordinate axis at some point. I don't know which point it is touching, so I call it as an arbitrary constant A. Hence my number of arbitrary constant is 1. Hence my order is also 1. Okay, fine. Moving on to the next question now. The differential equation x is equal to, this has been popping up nowadays in many places, this question. We don't know what is the reason for it, but this is coming up in many papers. So I thought I'll also include this in my discussion. dy by dx, the whole cube plus etc. up to infinity. This is actually an expansion of a particular function. A Taylor series expansion. You don't have this actually for your NCERT. Taylor series expansion for e raised to x. The Taylor series expansion for e raised to x. It is like 1 plus x squared by 2 factorial plus x cubed by 3 factorial plus etc. So the Taylor's series expansion for e raised to x is this. Now instead of x, can you see everywhere it is dy by dx? So can I now conclude that this is actually x is equal to e raised to dy by dx. Once dy by dx x appears in the question, definitely it's a differential equation. Now can anyone tell me what's the degree of this differential equation? Anyone tell me degree of this differential equation? Quick, let's not waste time. Quickly, you can give the answers. What's the degree of a differential equation where the dy by dx sits on a non-polynomial form e? I expected many of you will say option C, not defined. Again wrong. Again wrong. It's not defined is wrong, because I can invert this e and I can write it as log x equal to dy by dx. Now my differential coefficient is free of the non-polynomial form. Though there is a log x, that log is sitting with x. X is not a differential coefficient. My problem arises for degree if my differential coefficient, that is dy by dx, is inside a non-polynomial function. Yes, but my dy by dx is free of any non-polynomial function. Log x is sitting on the left side. So I can say from this that my degree is 1. Again, learn from your mistakes. Learn from the mistake is the best way to not forget these questions. Okay, so take this e to the left side and make it log x, and my answer is degree 1, option B. Yes, right answer. Get it, all of you? Very good. Very good, all of you. Going on to the next question, question number 16. Now tell me what is the degree of this. Now can you please tell me what's the degree of this? 1 plus dy by dx plus d squared y by dx squared equal to e raised to dy by dx. Can you please try to tell me what's the degree of this now? Come on guys, give it a try. Give it a try. Yes, some of them started saying degree is 1. Some of them started saying degree is 1 because they think I will, again the same way, I will invert it this side. Log 1 plus dy by dx plus d squared y by dx squared equal to, sir, I freed my dy by dx of the non-polynomial form e, but on the left side, two other differential coefficients, dy by dx and d squared y by dx squared, are trapped inside non-polynomial function log. Okay, so, and because of that simple reason, where log is having the differential coefficients inside them, degree not defined, my dears. Degree is not defined. Option D. Option D is your answer. Yes, now right answer coming up after explaining that idea. Very good. Very good. You understand. That's why I purposefully put this question after that. So you will have that idea. If this comes in the exam, you will do the same thing. If you know this, you will do the same thing for the other one also. But remember, non-polynomial function doesn't always mean that degree is not defined. You could try to rearrange it somehow where my differential coefficients are all free from non-polynomial forms. Okay? If you're not able to make them free, then close your eyes and tick that it's a not defined degree. Okay? Moving on again. Question number 17. The differential equation cot y has a solution. Easy question. Not going to waste too much time explaining this. It's a separable form. You get cot y dx equal to x dy. So it's going to be cot y to the other side. It's tan y. Dy is 1 by x dx. So you will say log x is equal to integral log x is equal to log sec y. And we know that whenever there is a log for both the parts, you will apply it as log c. So you'll say log x is equal to log c into sec y. Take out log on both sides. X is equal to c into sec y. So you can see it in option B. X is equal to c sec y. X is equal to c sec y. Right answer, Nitin. Right answer, Drivil. Okay. So question number 17, again a solution type question. Now let's move on again. Question number 18 here. The differential equation. I said one more question is going to be coming from circles. Finding the order, right? The differential equation of all circles of radius 3. Differential equation of all circles. Where is it? On the coordinate axis, where is it placed? That I don't know, sir. I don't know where it is placed. Previously it was set in the first quadrant touching both the axes, but here it's not mentioned like that. It just said that the radius is 3. And we don't know what's the coordinates of the center. Let's call it as h comma k only. And what is the equation of my circle? Equation of the circle is x minus h squared plus y minus k squared equal to r squared. I don't know what are the coordinates of my center. No idea about that is given to me in the question. And my radius is but 3. So I can call it as 9. How many arbitrary constants? How many arbitrary constants? 2, right? Number of arbitrary constants is 2. So number of arbitrary constants equals number of arbitrary constants equals 2. Therefore, what is going to be the order of my differential equation? Order is also 2. What's the order? Option A, 2. Now, do you see that the relationship that exists between the order of a differential equation and the number of arbitrary constants? A new pattern. So we learned 4 patterns now. Simple order and degree, finding of the simple order and degree of a differential equation. Second one, finding the integrating factors of LDE. Third one, simple solutions of differential equations. Now fourth one, relationship that exists between the order and number of arbitrary constants of a differential equation. Got it? That's how we've covered 4 concepts now. And also one more, I forgot about that. Solving a differential equation and telling which geometrical shape it represents. Okay, moving on, question number 19. Again, solve a differential equation. So yes, it's a separable form. Straight away I'm writing it. Dx by 2x plus 3 equal to dy by 2y minus 1. Integrate both sides. You will get log 2x plus 3 by 2. Log 2y minus 1 by 2 plus log c. So everything is in log, so my arbitrary constant is also a log. So you get log 2x plus 3 equal to log 2y minus 1, because divided by 2 is common everywhere. Apply that 2 on log c, but still it remains what only? I told you, C is such a form, he can eat anything. He'll still remain C only. So this is going to be log of C into 2y minus 1 is equal to log of 2x plus 3. And log goes on both sides. Your answer is 2x plus 3 is equal to C into 2y minus 1. Okay, and you bring it to the left side. 2x plus 3 divided by 2y minus 1 equal to C, option B. 2x plus 3 divided by 2y minus 1. Yes, right answer already came from Nitin, Dhruvil. Good answers. Okay, 2x plus 3 divided by 2y minus 1 equal to C. Simple question once again. Solution. Question number 20. Okay, again integrating factor. Integrating factor, I have to divide this x over here. So I will get my P as log x divided by x. So my integrating factor is equal to e raised to integral log x divided by x. Again, method of substitution. Put t is equal to log x. The derivative of t is 1 by x dx. Derivative of t is 1 by x dx. So your answer is going to be e raised to integral t dt, which is e raised to t squared by 2, which is e raised to, or root 1 by 2 means root e raised to t squared, which is root e raised to t is log x. So root e raised to log x squared. Root e raised to log x squared. Option C, root e. Why root e? Because it's t squared by 2. 1 by 2 represents square root. 1 by 2 represents square root. Okay. Moving on. Once again, the differential equation represents what? The differential equation represents what? Y into dy by dx is equal to c minus x. Y dy equal to c minus x dx. Integrate both sides. What is the integral of y? Y squared by 2. Integral of c, cx minus integral of x, x squared by 2, okay, and plus some arbitrary constant k, because we are trying to solve it, right? So now please listen very carefully to this rearrangement. Bring x squared by 2 to the left side. You have a y squared by 2 already there, and you are having a minus cx minus k equal to 0. Because k is an arbitrary constant, it can take any sign, so it still remains k. Now it's going to be x squared plus y squared minus 2cx. Again the 2 will go to k, but still k remains k only. This represents what? Can anyone tell me? This represents what? This represents x squared plus y squared usually represents a circle. Yes, it represents, but two options are there with circle. A family of circles with center on y-axis, a family of circle with center on x-axis. I would say option. Nobody has given that answer. It's center on x-axis because it does have an x coordinate. There is no y coordinate. Y is 0. Y coordinate is 0. Y coordinate 0 is happening only on x-axis. So my center lies on x-axis. So it's a family of circles with center on x-axis. Most of you saw family of circles ticked away. They did not read the entire option. Read it properly before coming to an answer. Okay, it's a family of circles with center on x-axis. Okay, good. Let's move on now to the next question. The order of this is a very, very important type. It looks a very complicated form, so let me write it first. Y is equal to C1 e raised to 2x plus C2 plus C3 e raised to x plus C4 sine of x plus C5. This is the solution of a general solution of a differential equation. Count the number of arbitrary constants. 1, 2, 3, 4, 5. They purposefully gave you C1, C2, C3, C4, C5 to count the number of arbitrary constants as 5. So you will go and take option A, but that is a wrong answer. Okay, please listen to what I am doing here. C1 into e raised to 2x into e raised to c2. 2x plus c2 is e raised to 2x into e raised to c2. C3 e raised to x. C4 sine x plus c5. Okay, can you see that these two arbitrary constants are being multiplied here? So when they multiply, they will become a new arbitrary constant called k1, and that will stay with e raised to 2x. And c3 doesn't go with anyone, c4 doesn't combine with anyone, and c5 is inside the trigonometric form sine. It doesn't go with anyone. Now please count the number of arbitrary constants. 1, 2, 3, 4. Option B. That is where you have to be careful. You see such an expression with so many C's coming. Definitely remember that there could be some C's which can be combined. There could be some C's which can be combined. Okay, so let me show you one more question quickly. Just I need 10 to 15 seconds for that. One more question here. Do you see this question here? C1 plus C2, C3, C4 and C5. I can combine these. Normally you would say 5, but I can combine this and call as K. But the C3 inside cos function I cannot touch. But the C5 sitting here, it can be written as e raised to x into e raised to C5. And that will be combined with C4 as another arbitrary constant called K2. So I got K1, I got K2, and then these two are gone. These two are gone. Now count the number of arbitrary constants. K1, C3, K2. You have only 3 arbitrary constants. Careful. Very important. Mind you, very important for this year's exam. The number of arbitrary constants and order of a differential equation. Yes, and that was the last question for me today. And I think everybody is clear with the different types of MCQs is going to come with the differential equations chapter. So I'm going to sign off today with this topic right now. I'll come back again with another topic very soon. Thank you for hearing out, and I see you all. Have a very nice day.
Brilliant Qatar, your trusted coaching partner for IIT, JEE, NEET, Science and Commerce tuitions with 10 years of excellence in quality training. Brilliant Qatar.